91.
91.
Okay, great. Huh. Great counting. Both of you, great counting. So how many have, so there'll be 91 cases where somebody answers yes to, do you have at least one 6?
Mm-hmm. Yeah.
How many times do they have 2?
Well, so now you have to look at some of the corners, or maybe the edges. So, I guess you have to look at the different cases.
All right, can you show me a cube that would have 2 6s?
Well, if you went the gold 6 this way, and then the black 6 is 6 up, so this one.
All right, nice. Okay.
And then there's with the purple 6 and then gold, so these 2.
Yeah.
And then the last case would be the purple and the gold, which would move over here. So these 3.
Okay.
So it's 3 out of 91.
All right.
Of 2, and then it would just be the 1. Well, this one would have 3, so 4.
Okay. Can you tell me about this cube here? What does this one have?
So that one has. So you do have 6 in the gold, 6 in the black, but you've gone over a bit.
Yeah. So what did I roll on the purple on this one?
It's rolled a 4.
Okay. So I have 6 6 4. So does this one have more than 1?
So I think you have to count the edges too.
All right. So what would you say there are? How many?
So I'd say there are 16.
Okay. And what are they?
So it's on my method of counting. It's we're doing 2 or more, or just 2.
More than 1. Yeah.
So it's these. We got the sets of 5. This 5, this 5, and this 5, and then you've got the corner.
Okay. Does that make sense?
Yeah.
All right. So we've got 16. 16 out of 91. Okay, now 16 times 6 is 96.
Yep.
So maybe we're close. I'll tell you exactly what that is. I'm going to find my calculator on my phone. 16 divided by 91 is about, we'll call it 18%.
But with this counting method, aren't you not? So you're counting these, and then you're counting this corner?
Yeah.
But what about these corners here?
Well, didn't they get counted when we did our 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Yeah, so
Does that
they
make
did,
sense?
yeah.
Okay. Now, what if I said I rolled a 6 on the gold dice? Which edge or which face of the cube is the 6 on the gold dice?
It's the blue face.
So now this is my 16 out of 91, or about 18%. If I say, did you roll a 6? And then did you get 2? Now if I say, did you roll a gold 6? What's the probability that you have more than 1 6 now?
Well, so now you have 5, and you have 11.
Okay. And how many times, how many cases were there that you rolled a gold 6?
Well, it's 11 out of 36.
11 out of 36.
That's roughly.
Call it 31.
It's around a third.
So again, with just the gold 6, it was higher probability.
Yep.
So does this help make you believe the ace paradox?
Yeah.
Yeah.
And why is this similar to the ace paradox?
Well, so you have a set that you're, I guess, restricting more with your first condition, or that makes it result in a higher probability for the second condition, which is the same between your 2 options.
Mm-hmm. And what would you say?
Well, you're kind of comparing like the different 6s to like the different aces. So even though you have like the same quantity of things, you're picking one specific 6 or one specific ace, and that is going to give you a higher probability.
Yeah, the interesting thing is we threw out lots of ones like these lower squares here on the top. We threw out, when we restricted to the gold 6, we threw out lots of cases where there was only one 6.
Yeah.
But all we threw out were these 5 cases where there was more than one. So we threw out lots of single cases, but not so many double cases.
Yeah.
So that's interesting. So tomorrow we'll calculate the numbers in the futility closet. All right.
All right.
Good job today, guys.